Jaquar Group, built on the standards of highest quality and aesthetics. In over 60 plus years, we have pioneered the concept of sleek and aesthetically pleasing products that are reliable and durable. As a global super brand, Jaquar's vision is to inspire people worldwide to rediscover the joys of water and light. The group's lighting division too has been setting new parameters of excellence, witnessing unprecedented success, thus providing complete smart LED lighting solutions to consumers across the globe. A state-of-the-art unit situated in Bhiwadi, Rajasthan, sprawls over 55,000 square meters floor area. The unit has 11 different departments through which Jaquar aims to bring the lighting revolution. And for an in-depth understanding of what goes behind making these meticulous products, let's embark on this illuminating journey to know more about these processes. Jaquar Bath and Light conducts groundbreaking research and development that exceeds lengths and breadths in terms of innovation, quality, and technology. We use an integrating sphere system which measures light output and quality. This machine aids photometry and optical testing, and it takes on multiple testing parameters. We are also equipped with a 0.5 meter version of the integrating sphere system that measures the total light output and quality of individual LEDs. The testing laboratory also has a gonio-photometer installed in a temperature-controlled dark room. Its results help to simulate the ambience of light and intensity after installation in commercial, outdoor and indoor spaces in accordance with LM79 standard. Used for the first time ever in India, Jaquar Group also has a robotic gonio-photometer. It measures accurately and gives faster photometry results. It is a multi-axis gonio-photometer configured for measurement and evaluation of technical characteristics of all types of lamps and luminaries. To implement electrical testing, an AC-DC power source and LED driver tester is used, specifically for LED driver. Along with these, we have surge generator, which provides safety testing. It simulates the surge at line, neutral and ground up to 20 kV. A high pot tester is used too. This powerful machine is used to check electrical strength of a product and LED driver. It allows us to perform multiple tests in a sequence AC, DC, IR. Then to test endurance, humidity chamber and oven is brought into effect. It can test the product while it is in on state and at different voltages ranging from 80 volts to 400 volts. It is followed by IP testing, which is used to test liquid and solid particle ingress protection. Products undergo specific testing procedures wherein different water intensity and pressure is applied on the product. To ensure longevity of products, a salt spray test is conducted. The salt spray chamber tests corrosive effects by simulating salt spray corrosion in an atmospheric environment. Then comes glow wire test system, which tests flame resistance of lamps and luminaries, electric heating the wire using large current. A temperature of 550 degrees Celsius to 960 degrees Celsius is required. It burns the sample for 30 seconds vertically and then evaluates the ignitability characteristics of the material. To check flame resistance, a needle flame tester is used to evaluate the gravity of danger of the flame caused by the faulty condition inside the equipment. A needle burner with butane or propane gas ignites the sample at a set time and angle. For inspecting products, a digital microscope is used to view small electronics components for analysis purposes, creating full HD 1080 pixel images. The next manufacturing process is die making, which is crucial to determine precisely shaped lights. We use SolidWorks software solutions to ace product design and provide technological solutions by recreating 3D models of new product housings. Die design is used for 3D modeling, engineering, and manufacturing activities to transform the product development process. A lathe machine is also put to use for rotating a workpiece to perform operations such as turning, facing, knurling, grooving, etc. with the help of various tools. Then, a milling machine uses rotary cutters to remove extra material by advancing a cutter into a workpiece. After the die is ready, the casting process comes into effect, shaping up an object efficiently in a regulated duration of time. We have deployed an electrical holding furnace that helps in the process of casting makings as per die. Then it is used to make housing by forcing molten metal under high pressure using the mechanism inbuilt in the machine. CNC Turning Center helps in the manufacturing process in which bars of material are held in a chuck and rotated while a tool is fed to the piece to remove material to create a desired shape. Additionally, we have a brother compact machine center with pallet changer to achieve high productivity. This is preceded by matchless drill-cum-tapping machine, which is used for drilling and tapping the component. We also employ a belt grinder lancer that is coated in abrasive material that is run over the surface in order to remove material or produce a desired finish. Then we proceed to powder coating, which is a superior technique to protect products against corrosion, flaking, and scratching. We start off with shot blasting machine. It is a method through which it is possible to obtain excellent cleaning and surface preparation for secondary finishing operations. Then, the powder coating process is done to make the housings last longer. After shot blasting, the housings are uploaded in an automatic 250-meter long conveyor belt with 300 hangers that passes at 2.5 meters per minute speed. Now comes 7-tank process. In the degreasing first step, heated chemicals 45 to 50 degrees in the caustic base are sprayed on the housing through nozzles to get rid of oil, grease, etc. In degreasing second step, same process is repeated to ensure no oil or grease is left. Then, water rinse 1 takes place to remove any chemical from the surface. Water rinse 2 is the repeat process to ensure no chemicals remain on the surface. Then, DM water rinse 1 takes place. The housing on the conveyor belt passes through a tank where D-mineral water is sprayed to remove any iron residue to ensure that it will not get rusted. After that, nano coating is done. A special chemical is sprayed on it to make a thin film of up to 20 to 100 nanometer micron so that powder can stick to it homogeneously. Finally, DM water rinse 2 takes place to remove any chemical left over during the nano coating process. There is an additional DM water tank to ensure that if by chance any chemical residue is left, it can be washed. After the 7-tank process, powder coating and baking is done to create a hard finish that is tougher than conventional paint. The conveyor passes through a blower to remove the water from the surface of the housing. Then it passes through the WDO chamber where the temperature is 100 to 120 degrees Celsius to dry water on the surface. The belt goes to a powder coating chamber where 3 automatic guns on both sides spray dry powder continuously on the housing. The powder that falls on the ground is supplied to the cyclone through suction. For any area where powder is not properly coated, powder is sprayed through a manual gun. After this process, the housings are baked in a furnace on 190 to 210 degrees Celsius temperature. A loop is created inside the furnace in such a way that each product gets baked for 15 minutes. Once it comes out of the furnace, it keeps moving in a loop in open air for 10 minutes to get cooled. It is then taken out and dispatched to the assembly section. After being inspected properly, Jaquar operates a surface mounting technology best suited for versatile and practical lighting solution. SMT has a Fuji Flexa software that is used for programming of pick-and-place machines. It enables editing programs online and reviewing production reports. The software shows all the error logs that occur during production process. It also contains a vacuum loader that sends the PCB to the printer. It has vacuum pins on the top side of the table, which helps PCB to come on the conveyor from the stack. This is a solder plate or glue printing machine with a host of features. Along with it, a solder paste inspection machine is used to inspect solder paste on the pads of PCB to avoid defects after reflow machine in the soldering joints. We follow it with a pick-and-place machine, which has its own camera to cross-check the component position loading done by the operator. It gives proper feedback to the operators. After pick-and-place components, a reflow oven machine is used for the soldering process. It has a double conveyor and an inbuilt oven temperature safety system which controls the temperature. Furthermore, LED manual testing examines each module to guarantee that no defective modules are delivered for assembly. There is another PCB making line, PCB making line 2, for fabricating circuit boards containing electronic components. It enables the examination of production reports and logs errors generated during production. It helps us to do online editing in programs while the machine is in the running mode. Subsequently, a solder paste glue printing machine comes into action, connecting printed circuit boards to surface mount components to pads. We also have a buffer machine that can store up to 20 ng PCBs. It is generally used after the inspection machines, SPI, OR, AOI. Apart from that, a shuttle conveyor machine takes single lane production and further converts it into double lane production for the next machine and vice versa. The Fuji NXT3 machine that can achieve CPH, component per hour, of around 50,000 components with H24 head in one module and further expandable to any limit by adding more modules. This is preceded by the automatic optical inspection machine used to inspect solder joints after reflow. We are also equipped with the magazine unloader that helps receive PCB from AOI in finished condition and can adjust up to 600 mm PCB size and length. Now the manufacturing process takes place in the SMT automatic and manual insertion section where drivers are made. The process begins with a component lead cutting machine designed to trim the component leads of PCB assembly before the soldering process. The component value is manually checked before cutting the packet. Components are dropped in the vibrator pot and set on track for cutting as per required length. To avoid inconsistent shape or size, manual insertion operator inserts components on printed circuit board as per the BOM. For great results, the team is trained weekly to improve quality, maximize production, and check right placement of PCB components. 5 state-of-art machine with first in India setup inserts components on printed circuit board as per the BOM with a capacity to hold 20 rolls in one feeder. The uniqueness of using the automated machine is consistency of product quality and quantity, high throughput and productivity, and also the automatic inventory tracking. The wave soldering machine applies a layer of flux to the underside of the entire board. Flux is used for better soldering result, and we use lead-free solder for soldering. Now comes the lead cutting procedure. The conveyor is set according to PCB size and the cutter is set according to lead length. One operator is required for product safety and machine safety. A pair of conveyor chain clamps the PCBA for transporting into the high-speed turning blade. Wrap prevention device in the equipment ensures no damage on the board. We also use wire cutting machine for cutting, stripping and twisting of wires according to BOM specification. Wire tinning in solder pot is used to improve mechanical strength of copper wire. To check final output, touch-up line is used to identify product defects and eliminate them. Following this, the automatic driver tester starts to check the different electrical parameters of the electronic driver like wattage, current, voltage, power factor and puts the mark on failure driver. After visual inspection, finished goods are packed in ESD bins one by one. At the end, a sticker is put on it. It is then sent for final quality check, after which the driver aging machine checks the electrical parameter of the electronic driver in a specified time limit on resistive load. Up next in the manufacturing process are LED assembly lines in which workers progressively assemble objects to the final products one by one. There are numerous assembly conveyors in the unit that put finishing touch on various light products. We use this machine to test LED lamps on different voltages and temperatures to understand stability of the product on different voltages. LED module cutting machine is used for removing the LED module of tube lights from the panel. Next, a laser printing machine is used for laser printing a product specification and company's logo onto the product. Now we'll take an in-depth look at the bulb making department, where best-in-class techniques are used to produce industry-standard products. A total of 6 processes are performed to create a bulb, starting with PCB assembly, which helps in connecting electronic components to one another in a controlled manner. Next up is the cap machine. Air pressure in the cap machine is checked before power is turned on. If air pressure is okay, then power is turned on and the computer button is pressed. Then comes the gluing process. Next, aging is done to discover the longevity of a product. Now, laser printing takes place. Finally, to add branding into every product, laser printing is done to every product to give them the Jaquar identity. Every bulb is packed to perfection, keeping in mind the safety parameters. Now let's understand what processes go into making premium Jaquar chandeliers. Under this process, hole marking is done as per the design and then it is bent manually and mechanically. Under this process, the marks for holes are drilled and filled to give the product edges a smooth and shiny finish. Now the brass parts are joined using electrical and gas welding. After welding, the parts go through a grading process to smoothen the products and give a shine like never before. Hand-picked crystals are then chosen and placed as per the drawing to give the chandeliers a perfect finish. Once the chandelier is ready, its full load testing is done to ensure the durability of the frame as well as electrical components. After the manufacturing process, these products are kept in a cutting-edge warehouse that strengthens production and drives the operations. The warehouse is equipped with a massive storage capacity. From here, the finished products are also exported to different parts of the world. Now a quick recap of all the departments that make these world-class products. As a leading lighting company in India, we are committed to providing complete LED lighting solutions for residential, commercial, and outdoor use. We have a manufacturing strength of producing over 25 million products annually, designed to be compatible with and complement every interior and exterior design, aesthetic or decor. A true manufacturing excellence by Jaquar Group.